We have been learning to solve systems of equations. So today we're going to look at all three methods and kind of talk about how to decide which is the best way to solve. So your essential question is, how do I solve systems of linear equations? Your learning intention: I am learning to solve systems of equations by any method. So for your warm-up, solve the first one by graphing. Pause the video and see if you remember how to do that. Well, I do hope you tried to do it on your own. Remember, we always begin at the end. So for the first equation, we begin at 3, and we move negative 7 thirds, which is down 7, and then right 3. So I'll start at positive 3, then I count down 1, 2, 3, 4, 5, 6, 7, and I go right 1, 2, 3. I now have 2 points, and I can graph that first line. For the second line, where do we begin? We still begin at the end, so we begin at negative 3. I move negative 1/3, which is down 1, and then right 3. Down 1, right 1, 2, 3. We now have identified our point of intersection. So my solution is the point 3, negative 4. Okay, so as we're looking at this, we always are trying to see if they intersect, or if they're the same line, or if they're parallel. Because your solution to the systems are the point or the points in common. Sometimes it's easier to solve systems by substitution, sometimes by elimination, and sometimes by graphing. Graphing you have to be very accurate with. So if I'm looking at the next one, step 1, decide which way I'm going to solve. Looking at it, I notice they're both in slope-intercept form. If they're both in slope-intercept form, graphing would be the easiest. Okay, substitution would almost be as easy. But with the fractional coefficients of x, we might want to just go ahead and graph. So for the first one, I begin at 2. So I'll put my point on 2. I move 3/5, so that is up 3, right 5. Start here, I go up 1, 2, 3, go right 1, 2, 3, 4, 5. I am now ready to draw my line. Okay, for the second one, where do I begin? Begin at the end, so I'm going to begin at 3, or at 4. So I put a dot on 4. How do I move? 1 over 5, so that is up 1, right 5. Go up 1, go right 1, 2, 3, 4, 5. I didn't begin it. I did not go from the right point. I started at the wrong point there. So start at 4, go up 1, go right 1, 2, 3, 4, 5. I've now found my point of intersection. So what is the solution in this case? The solution is the point 5, 5. So we've gotten the first one done by graphing. If I'm looking at this second set, I notice really quickly that I have opposites here. It's all lined up. This one is definitely easiest with elimination. I don't have to do any multiplying. I just have to add straight down. This term is gone. 8y minus 6y is 2y. 8 plus 12 is 20. 2y equals 20. I'll divide both sides by 2. And y equals 10. Okay, now I can use either one of these two equations. Does it matter which one? Not really. So I'm going to choose to use the top one. 9x plus 8y equals 8. 9x plus 8 times 10 equals 8. Nine x plus 80 equals 8. Now I can solve. I will subtract 80 from both sides. Nine x is equal to 8 minus 80. They're opposite signs, so I subtract. 80 minus 8 is 72. Keep the negative sign because 80 is bigger than 72. Last step is to divide by 9. Can I divide 72 by 9 evenly? Yes. My quick test is to add those digits together. 7 plus 2 is 9, so I can divide by 9. X is equal to 8. So my solution is the point 8, 10. If you have any questions, back the video up and look at it again. Okay, for the next 3, you're given the Cartesian plane if you want to graph. You don't have to, but if that is your preferred method of solving, you can do it. Looking at the next one, If I want to graph, I would have to solve for y in both cases. If I look harder, I realize that if I multiply the bottom equation by 3, I will have created opposites. Okay, so the top equation, I will not change. I'll have negative 6x plus 10y is equal to 4. But the second equation, I'll multiply by 3. 3 times 2x is positive 6x. 3 times negative 6y is negative 18y. And negative 12 times negative 12 times 3 is negative 36. I've created my opposites. I can eliminate by x variable. 10y plus negative 18y, they're opposite signs, so I subtract. 18 minus 10 is 8. Keep the sign of the larger number, which is 18. Negative 8y is equal to 4 plus negative 36. Once again, they are opposite signs. 36 minus 4 is 32. Keep the negative because 36 is bigger than 32. Last step to solve for y is to divide by negative 8 on both sides. And y is equal to 4. So, I found y. It's time to find x. Which one do I want to use? Doesn't really matter. The top one will be not too bad. So I will take negative 6x plus 10y is equal to 4. Negative 6x plus 10 times 4 is equal to 4. Negative 6x plus 40 is equal to 4. I can now solve. Subtract 40 from both sides. Negative 6x is equal to opposite signs, so I subtract. 40 minus 4 is 36. Keep the symbol of 40 because it's the largest number, so it is negative 36. Divide both sides by negative 6. And x is equal to 6. So my solution is the point 6, 4. By scaling one equation, we're able to solve. What about the next one? Actually, there's two different ways that are equally easy to do. I could solve for y and substitute, or I could multiply the top row by negative 6, scale that top one, and I could do elimination. So today, if we wanted to, we could solve both of them for y and do graphing also. But that would be a little bit more work. So I think today, for this one, I'm going to solve for y and use substitution. I'm going to use substitution. So by adding 5x to both sides, I get y is equal to 5x minus 2. I am going to substitute that into that second equation and solve. Negative 3x plus 6 times 5x minus 2 is equal to negative 12. Okay, negative 3x plus 6 times 5x is 30x minus 2 is equal to negative 12. Combine your like terms. Negative 3x plus 30x is 27x. And this should be minus 12 here, because 6 times negative 2 is negative 12. So 27x minus 12 is equal to negative 12. Add 12 to both sides. 27x is equal to 0. And x will be equal to 0. Okay, so what is y? Well, I'm going to use my equation up here. Y is equal to 5 times 0 minus 2. Y is equal to negative 2. So my solution is the point 0, negative 2. Any questions? Okay, for the last one, it can either be done graphically if I solve the first one for y, or I can do it with substitution. Substitution is probably the most accurate because we might or might not get a whole number here to be able to start on, because we would have to divide negative 1 by negative 3 to get our b value, or our beginning value. So substitution again is probably the best method. So I'm going to take, I know what y is equal to, and I will substitute it into the other equation. (2x minus 3 times x minus 1 is equal to negative 1. All I did was substitute in. Distribute. 2x. Negative 3 times x is negative 3x. Negative 3 times negative 1 is positive 3. Negative times negative is a positive. Is equal to negative 1. Now I'm ready to combine like terms. 2x minus 3x is negative 1x, or just negative x, plus 3 is equal to negative 1. I will subtract 3 from both sides. The opposite of x is equal to negative 4. If the opposite of x is equal to negative 4, then x must be equal to positive 4. I still have to find y. So as I'm looking, y is equal to x minus 1, but x is 4. Y is equal to 4 minus 1. Y is equal to 3. So my solution is the point 4, 3. So as you're doing the systems of equations, take a minute and look and see which method would make the job easier. Sometimes you'll go to the same method a lot because that's the way you prefer to do it, and that is fine. But always choose a method that will work for you. How do you know when you're successful? You know when you're successful when you can decide which method to use when solving systems of linear equations and then solve them. So this is deciding the method to use to solve linear systems of equations.